Good morning, everyone. I'm Stefania Cusateri, and I will be your moderator for today. Welcome to the meeting, and thank you for your participation and for taking care for this session. Thank you to the speakers and to the audience. Before starting, I want to remind that this event will be recorded as you hear. Now I would like to take a few moments to introduce on our
Stefania, you are now muted.
Can you hear me?
Yes.
Okay, sorry. So I would like to take a few moments to introduce our panel. So improving the sustainability of maritime transport in the Adriatic Sea. The question is, how can the environmental sustainability of maritime transport in the Adriatic region be improved? So this is one of the main goals of INTERREG IHR, the Italy-Croatian cooperation program financed by the European Regional Development Fund. And we are here with some of the representatives from Echain, enhanced connectivity and harmonization of data for the Adriatic intermodal network. We are here with some representatives from GUTTA, saving fuel and emission from maritime transport in the Adriatic region, and METRO, maritime environmental friendly transport system. So we will describe the outcomes of the project activities and the experiences, the lessons learned during the project. And moreover, thanks to the speakers from the European Agency for Maritime Safety and with the Catena SPA and the representative of the Port Network Authority of the Eastern Adriatic Sea, we will discuss also about the present and the future of maritime transport regarding sustainability. Now that we have introduced our panel, please join me in welcoming Paolo Rotoni, Mr. Paolo Rotoni, for the institutional greetings from INTERREG VA Italia-Croatia.
Good morning to everybody. I'm very happy to say to this event because this kind of event is very interesting for our program because we push all the projects to realize these events, to put together different partnership and different knowledge about a common topics. As you probably know, okay, I will show you just one slide, just to very brief. There is no intention to make a presentation, but only to have an overview of our program. Probably everybody knows this program started in 2016, and of course this program will be repeated in the next programming period. So we have now more than 80 approved projects and just around 800 project partnership, as you can see in the slide. And you have to consider that this program is one of the biggest program of the territorial cooperation in Europe. And for the next programming period, we will have a new program with this, more or less with the same territorial coverage. So as you probably know, because probably you work on in this project, we have different outputs and activities that the program realizes. So more related with the feasibility studies or activity related with improving the cooperation among the stakeholder and the beneficiary of the territories. So in some cases we have some interesting infrastructure or small infrastructure or pilot action, a lot of pilot action, especially this program in this period had a lot of pilot action. So that means that there is the real intention of the stakeholder or the beneficiary to improve the quality of the cooperation among the two countries. So I don't want to add other issues because the floor is from the expert now, but I take the opportunity to remind that in a cluster call is open. It's a small call that allow you to capitalize your results. So for instance, a project like this kind, 3 projects probably could be interested to think to improve the collaboration among you. And so I will invite you to see the website to participate. If you have any requests of information, don't hesitate to speak with me or with my colleague. Okay. So that's all for the moment, and it's okay. So the floor of the moderator.
Thank you, Mr. Paolo Rotoni, for your greetings. Now we will start with the first part of our panel. And I would like to introduce the first speaker, Dr. Emanuele Giglio from GMT SPA, project partner of Echain project. Please, welcome.
Okay, good morning, everyone. Now I will send the... Okay, first of all, I want to thank all of you for this opportunity to be here and show our work with Echain. I'm Emanuele Giglio. I'm from GMT SPA from Italy, and we are one of the partners of Echain INTERREG project. I work for GMT SPA, that is an energy service company, that is a society that is set in energy efficiency field. So when we are talking about to reduce the impact, the environmental impact of the mobility, the transport, it's something that we already do for with my society, and we work in the national scenario adopting efficient technologies in order to reduce energy consumption and GHG emission. When we talk about to reduce the impact of the environmental impact of the transport, we talk about to achieve it, we need to talk about energy efficiency. So that is the goal, to reduce the amount of energy required to provide products and services, and also reduce the effect of air pollution. Of course, one of the main questions when we talk about action to reduce, to put more energy efficiency in transport or in all other field, we have the one big problem, how to understand that one specific action is good or bad, or is a lot good or not. So it's possible to show how is possible to show this improvement in efficiency, how is possible to measure it. So in my brief presentation, I will show some calculator, some way to measure this GHG emission, for example, particularly the CO2 emission that represent the 80% of greenhouse gases. If we would be in an ideal world, to understand how we are emitting now, how much CO2 the transport is is emitting, we would have to put instrument in every vehicle that we have in the world. Okay, ideally, of course, this is not possible. It's far away to be realized. So we have to find a way to estimate this emission, to find a way to as much accuracy as we can, but simplify it. Of course, we have to remove some factors in this calculation. Exist several ways that are really different, and I will show you two of them, two of this calculator. That is the Copert calculator made by EMISIA, and Ecotransit World, that is a calculator, a website. We start with the Copert calculator. Why we choose this? We choose this calculator because it's the EU standard vehicle emission calculator. It's developed by EMISIA, that it's a spin-off company of the Aristotle University of Thessaloniki. And it uses vehicle population. So we are talking about something about terrestrial vehicle to calculate the emission and energy consumption of this type of transport. Copert is coordinated, the development of Copert is coordinated by the European Environment Agency, and in the framework of the activities of the European Topic Center for Air Pollution and Climate Change Mitigation. And also the European Commission Joint Research Center manages the scientific development of the model. So Copert is something really official, and the characteristic of the Copert is that it's internationally recognized. It is used by many European countries for reporting official emission data. It's an incredible research tool. It's used from a lot of universities use it to calculate emission nationally, regional, also on local scale. It is technologically advanced and transparent. The methodology is published and peer-reviewed, and includes different type of pollutants, greenhouse gases, air pollutant, and toxic species. Copert estimate emission from different type of road vehicle, and also in different type of operation modes. So we're talking about the thermal stabilized engine operation, so the hot emission, the warming up phase, and then not exhaust emissions. So when we're talking about the fuel evaporation, the tire and the brake rear emission. As we say, the Copert have a really big, possess a lot of data for more than 450 individual vehicles, just like include passenger cars, light commercial vehicles, heavy duty vehicles, and L category vehicles. So we, as Echain, we decided, because our project, and then after I will show you this something about Echain, we'll use Copert or something to calculate the emission, the CO2 emission about the transport. Then we will see a bit further, a bit better how. The other calculator that I want to show is this Ecotransit World calculator, and I decided to show it to you just because it's one of the most widely used software for automatic calculation of energy consumption, carbon emission, air pollutants, and external costs about different type of transport. So not just terrestrial vehicle. It's compliant to different standards. That it's really important because it gave scientific approval about this method, just like GLEC framework, UNIAN 16258, and GFG protocol. The characteristic that it's really important about this freight transport of this calculator, it's that it includes truck, ocean-going vessel, airplane, train, and inland waterway. So it can give you a real complete analysis about the CO2 emission of a particular path. Eco-transit world calculate energy consumption, greenhouse gases, air pollutant, and external costs based on energy-based bottom-up approach, including internal routing. As we said, the methodology is provided by independent scientific institute, just like also Fraunhofer Institute of Material and Logistics and IFU and Infras. The emissions are determined on the basis of energy requirement, using the associated fuel and other parameters, and a carrier-specific internal routing is the base for identification of the route characteristic. So these are two of the most widely used calculator, but always there are an estimation of CO2 consumption, CO2 emission about different type of transport. Differently is this regulation that I will show you now, because in 2015, the European Parliament and the Council of the European Union adopted this regulation, this 2015-757, when in this regulation, the European Parliament decide that they have to research something, to check how the big vessel will, how much CO2, the emission, how much CO2 they are emitting from the sea boat, from the ship. The regulation was about the introduction of a union MRV system, so monitoring, reporting, and verification, for monitoring CO2 emission for every ship in all intra-union voyages, all incoming voyages from the last non-union port to the first union port of call, and all outgoing voyages from a union port to the next non-union port of call. They were thinking, the idea when they decided to adopt this regulation is that every time you measure something, every time you have data about something, there is a natural improving of efficiency, that can lead the emission reduction of up to 2% compared to the business as usual. So they were thinking about that in this way. They would have a baseline about the CO2 emission of the maritime transport, and also an improvement of the reduction of the emission. Of course, this regulation is not, it will not be applied, is not applied to every type of ship, also because they have to minimize the administrative burden for ship owners and operators, in particular for small and medium-sized enterprise. So the regulation is applied only to large emitters. To do so was selected a threshold of 5,000 gross tonnage. They decided to take this 5,000 gross tonnage because it's just quite 55% of the number of ships calling into Union Port and represent around 90% of the related emission. So in this way, they will cover really the highest amount of the emission made by this type of sea transport. This regulation takes into account existing requirements and data already available on the board ships, and so they just they have to use one of these four way to calculate the emission. So to use the bunker fuel delivery notes, the bunker fuel tank monitoring on board, flow meter for applicable combustion processes, and direct emission measurement. So in this way, it would be, they have to, enterprises, they have to send this data at least every year. And in this way, it will be possible to understand how the maritime transport inside the Union, European Union is how much is emitting, how much CO2 is emitting. starting from this, we are talking about the Echain project. In what way we are using this type of measurement? What is our idea about to help to reduce the impact or environmental impact of the transport? The objective of the Echain project is to enhance connectivity and harmonization of data for the Adriatic intermodal network through the realization of modular software, Echain platform, for the management of intermodal transport services in port area for passengers to improve efficiency, quality, safety, and environmental sustainability of marine of coastal transport service, of course, between Italy and Croatia, specifically in 3 pilot sites that are Venice, Ancona, and Split. What we were thinking about the platform. The platform will include a touristic co-marketing tool, inform users about timetable of different operators, promote point of interest and events of the pilot site, provide real-time data about transport and tourism events, booking information, info-mobility system to inform and assist the users in different moments of their trip, interface with the local system to allow multimodality and intermodality, provided help desk assistance with big data management and upselling. So we are not talking about just a trip planner. What we want to create with this project is what we call a concierge. So someone that can help and can follow the passenger, the tourist, or the usual passenger from the planning the trip and during the trip and after the trip. And so some of the main features of this project, it would be to allow the integration between different services and systems for a multimodal transport, providing timetable and trip solution, optimizing resources, real-time events in a seamless solution, providing new services such as improved multimodal info mobility system in the port area for the passenger. So we're talking about how to help the passenger inside the port area to have interesting information, or so security information that in the last period we know how much is important to have this type of information, to facilitate purchase by redirecting the booking and the ticketing services of transport supplier. And as we said, we're talking about now, one of the main tasks is to increase the awareness of CO2 travel emission and enhancing the environmental sustainability of services. So one of our main goals is to show to every passenger how much their trip, how much the trip that they are planning can emit in CO2 by showing the different opportunity, the different way they can choose from one point to another. And so in this way, we want to show the people, the passenger, the different way that they can also emit CO2 by they choose path. And in this way, we think and we know that a lot of people will just choose the most environment, the less impact for environment. And so in this way, using all these data that we said, we can help to reduce the impact on environmental transport. So I was really fast, I know, but I think that and the other colleague will be much more specific about in their project about how to do. This is the way that Echain decided to pursue this reducing of the environmental impact of transport, just to give more awareness of the passenger to choose the best one. Thank you for your attention.
Thank you, Dr. Giglio. Thank you very much. Now the next speaker will be Dr. Gianandrea Mannarini, I will kindly ask to stay within your allocated time of 15 minutes for your presentation. Thank you.
Thank you, Stefania, for the kind introduction. I'm going to share my screen. So thanks again. And this is a great opportunity for us to tell you something about the GUTTA project, and some of its most recent results. I will not have time for addressing all items covered by GUTTA, and I will cover on just one of its products, which is the main one probably, and is a system for operational reduction of CO2 emissions from ferries sailing in the Adriatic Sea by meteoceanographic forecasting products. This is what I'm going to present. Please, I see a raised hand from Mr. Rotoni. Is there a question? Probably not. Okay, this is a joint work by a number of people in both Italy and Croatia, and they are listed here. So I'm very much in debt to a huge effort for realizing this system. In this presentation, after a short introduction, I will outline the architecture of this system, which we decide to call GUTTA VISIR. We'll present a few case study results before introducing you the web application we have recently launched. So the GUTTA project mainly deals with ferries sailing in the Adriatic Sea. And before focusing on the Adriatic, I think it's good to have the bigger picture of what's the overall carbon footprint of ferries in the European Economic Area. As the previous speaker mentioned, the European Union has set in place a mandatory system for monitoring, reporting, and verification of CO2 emissions from all ships, not just ferries, above 5,000 gross ton, calling it ports of the WEA. And now there are 3 full years data published by the European Maritime Safety Agency through their TETIS MRV portal. And if we look at this data for 2018, 19, and 20, we see, first of all, the order of magnitude of the emissions from ferries, which is about 13 million tons CO2 per year. If you want to have a feeling about this number, you could compare to the total emissions from all ships within the UMRV, which is about tenfold this figure, or to the global shipping CO2 emissions, which is about 100 times this figure. Of course, COVID had a huge impact on emissions, and a drop of about 20% in 2020 was observed with respect to 2019. This is, of course, not the decarbonization we want. This is something driven by an external shock, of course. So in order to address the issue of decarbonization, we should have also an idea about the efficiency of ships operating in Europe. And again, in particular about ferries. This map from a recent publication of us display the distribution of carbon intensity from ferries in Europe. And you see that the situation is quite diverse. Maybe there is somehow better performance of ferries operating among the British Isles, which is however, no more in the EU. But both the Med and the Baltic Sea, they have a quite diverse distribution of energy efficiency from ferries. This point about efficiency is quite relevant, as it is the subject of one quite recent regulation by the International Maritime Organization, which last summer in June exactly approved a measure, a plan, say, to reduce the carbon intensity of all ships globally, so not just ferries in Europe, according to a specific trajectory. So there is initially a very, very mild, very low, close to business as usual reduction, and then starting from 2023, there is an increase in the reduction speed for this carbon intensity figure. However, there are indications that this measure will not be sufficient for achieving IMO's goal of decarbonization, not even to halve emissions by half by mid of this century. So it is likely that this regulation will be soon reviewed for increasing the rate at which ships and ferries should increase their energy efficiency. Another important news came from the European Commission last July with the Fit for 55 package. This is a proposal by the Commission for new laws, which needs to be approved, discussed and approved by both the Parliament and the Council. But if approved, the Fit for 55 would include a kind of a revolution for the world of shipping, at least in Europe, since emissions from shipping would be included into the EU emission trading scheme. This means practically that a price should be paid by the polluter for the CO2 emitted by the ship. And this price can be quite considerable at present, considering the actual price of ETS allowances. This would imply about 200 euro extra cost per ton of marine fuel, which should be compared to about 500 euro per ton of traditional fossil-based fuels. So this would make fossil-based fuels less competitive with respect to low carbon or zero carbon fuels from the financial viewpoint, of course. In general, there are various measures for decarbonization, and the financial instruments, in a way, should bridge between short-term measures, short and long-term measures. Short-term measures should be applied already in this decade. They include the optimization of the voyage, the optimization of the speed, specifically a reduction of the ship, air lubrication systems for reducing the calm water resistance, or energy saving, other energy saving devices such as sails, both rigid sails, rotors, kites, and so on. In the long term, for achieving very big reduction in CO2 emission, one should resort, however, to low or zero carbon fuels, such as liquid ammonia or hydrogen, or e-methanol. There is a major company already planning to use e-methanol in the very near future. But our approach is to start from the short term and to offer something which can be useful not only for existing ships, but also for new ones. since even when these low carbon fuels will be available at scale, which is not yet the case, but even then, companies will need to save these fuels as much as possible, because this will be quite expensive fuel, and in some cases even very voluminous in case of hydrogen, for instance. So it is in any case mandatory to optimize route for minimizing consumptions, even though emissions are reduced or are close to zero. And so our solution for addressing this point of voyage optimization is called GUTTA VSEER. GUTTA VSEER is an operational system allowing any user, any end user like me and you and every attender of this webinar to go and visit a portal which is gutta-vseer.eu and find the freshest least CO2 routes for ferries operating in both the Adriatic and in the northern Ionian Sea. The architecture is quite complex. I don't think I have time now to dive into the detail, but basically it is funded on, it's powered by the VSEER2 ship routing model, which is an open source model developed at CNCC and has been validated versus a number of benchmarks, and is all available in these open access publications. You can download from vseer-model.net. But I have just 5 minutes to go to some of the results. For achieving these results, we used also data from a ship simulator installed at the University of Zadar, which is one of the partners within the GUTTA project. Basically, we have the capacity to compute how the ship behaves in both wind and waves. Specifically, as you would expect, the ship will decrease its speed. There is involuntary speed loss in waves, especially for Red Seas, and corresponding CO2 emission increase. And then we embed these into VSEER for the computation of optimal routes from Croatia to Italy and vice versa. We are able to compute both least distance, least time, and least CO2 routes, which can be different depending on the meteo-marine conditions. For instance, in this animation, you would see that for various departure dates and time, the optimal route changes, and correspondingly, the CO2 and carbon intensity saving. So this is the link to the IMO regulation I mentioned at the beginning of my talk. Basically, we are able, through this system, to compute what would be the carbon intensity savings for a ferry sailing, making expert use of the meteo-oceanographic information. In a publication we made last year, we started with a case study for assessing how large these savings can be, and they can indeed be quite large. But the definitive answer about this cannot come but from an operational system, which you access every day, starting from the freshest forecast data. And this is what we realized at gutta-vseer.eu, which I invite you to visit after this seminar, maybe. And I would really appreciate if you could provide your feedback as a user, since we are in a kind of a beta version, so it's in an experimental phase. And we are still some time before project end to improve a little bit the portal and the system to come closer to the needs of the users, both the professionals and then generalistic users. So this is just an overview of results from screenshots from GUTTA VSEER. For instance, here you see all the routes we can compute in the Adriatic and in the northern Ionian Sea. There are bundles of optimal route. Each route here is optimal for its departure time. We have the statistics on the carbon intensity savings, capacity to display the routes on top of the waves and the sea current fields, capacity to inspect the waypoint information of the route and export the route. So you can really download this route and bring onto your device, onto your navigator, for instance, and play with it, I mean, for instance. But the important thing is that once these routes are downloaded, this system becomes interoperable with other ones. And I'm thinking, for instance, at the recent developments in the sea traffic management project in Europe. Finally, 30 seconds to conclude. Ferries are the focus of GUTTA, and they are the focus of GUTTA for improving the connectivity between Italy and Croatia, and because their emissions are over proportional with respect to other ship types. The operational voyage planning is a solution for contributing to decarbonization for both old, existing and new ships, even for those fueled by low carbon fuels. We have realized this GUTTA VC service, which is based on a scientifically sound and open access model for ship routing. The service is freely accessible through an open web app. We have evidence of significant CO2 and carbon intensity reductions, of course, when there is some significant weather condition to be avoided. If the weather is calm, it's much more limited. And we are really looking forward to entering this phase where we validate this system together with the stakeholders, the ship masters, the vessel traffic systems, the ports, the harbors, and so on. So thank you very much for your attention, and see you later on during the panel.
Thank you, Dr. Mannarini, from Centro Europeo Mediterraneo sui cambiamenti climatici and senior scientist for GUTTA project. Thank you very much. Now I will introduce the third speech taken by Dr. Andrea Vincenzotti from University of Trieste, and representatives for Metro research project, and after that we will take 2 minutes for the first interactive polls. Please, Dr. Vincenzotti, welcome to the panel.
Thank you, Stefania. Greetings, everybody. I'm Andrea Vincenzotti from the University of Trieste. I'm the project manager for the Metro project. And today I will show you some of the results of our project in terms of how to design a sustainable maritime transport system. So you have already heard about these policies before in the presentation before. They are well known into the maritime sector, but I will remark just a little bit about that. In the past 10 years, a lot of changes have been done in regard to policies, to targets for reducing the impact of the maritime transport. And these new targets are very demanding. How we can design, how we can meet with these requirements in the short time we have, because we have already some demanding targets for 2030 and more demanding targets for 2050, sorry. Well, there are a lot of new technologies that are already on the market or are being researched, but they are at a high technology readiness level that can be used for reducing the ship emissions. Things like upward propulsion systems are being more and more used into new ships. Integration of energy storage system or fuel cells and so on is another thing that is being done actually in present. Also, we have seen that in the past 10 years, a lot of research, a huge evolution in digital technologies like big data analysis, machine learning, and so on, that can be used for a lot of things, like optimizing the use of existing ships, like Dr. Mannarini just said in his presentation from the project. You can use the technologies for design new ships to find the way to reduce bottlenecks in the ship operations, and so on. There are several research projects that address one or more of these topics. However, the problem is complex. There are several elements that are interconnected. We have heard something about that in terms of evaluating the emissions of the existing assets from the presentation of Dr. Giglio. But also designing new assets is difficult because we need to find a way to design a system which has a lower impact. This is difficult in the maritime sector because the maritime sector is peculiar in respect to other industrial sectors. One thing that we need to do actually is to provide a proof of concept of how new technologies can be integrated into ships. We have a lot of these pieces like a Lego, hybrid propulsion, energy storage system, and so on, and we need to put them together into a ship. And we need to demonstrate to the future ship owner that the integration of these components ensures the expected advantages. We need to have a lower pollution, but also we need to demonstrate to them that the integration of these new pieces does not make the ship worse in other key performance indicators, like reduce too much the payload. Moreover, we need to do that for each specific ship type because, I don't know, a dry bulk carrier is different from a tanker, which is different from a passenger ship. We need to do that for each different route, daily operative routine, specific work for ships that can do different works, and so on. And last but not least, we need to ensure the existence of the proper support land infrastructure. Example, we want to use ships with LNG, we need the LNG bunkering facility. And then we need someone who produces and transports the LNG to the LNG bunkering facility. So we need to shift toward a design approach which is more integrated. We don't want to design only the best ship for a specific application, but we also want to include into that design the entire value chain in which the ship is used, like the port and so on. This was the motivation for starting the Metro project. A short slide about the Metro project. The focus of the project is on the touristic connections in the North Adriatic area. The project, following this idea of applying a more integrated approach, put together both technological actions and logistic actions. The partners are depicted in the lower part of the slides, so I will not present them, but you will be seeing them for all the presentation long, so they are there. So being the maritime sector huge, we cannot do the project considering all the possible ships, all the possible routes, and so on. So we decided to focus on 2 routes and 2 ships. We've selected a short route, but with heavy traffic, which is the Brestova-Porozina route, which is actually served by a double-ended ferry. And then Kona Split route, which is a medium-length line, which is actually served by a roll-on, roll-off passenger ship. In this regard, we made the preliminary design of 2 new green ships using commercial off-the-shelf technologies, so nothing from research, only pieces that can be bought actually from the stores. And then we evaluated the port and land infrastructure that needs to be used for supporting these ships and proposing upgrades when needed. There is also a point on analysis and promotion of multimodal transport, which is more related to the Brestova-Porozina route because its ports are very small and they need more integration with the transport systems and so on. So this is an example of what we have done. This is the design of the bidirectional ferry for the short route, Brestova-Porozina, which we have done applying a data-driven design process. So we started from data of the existing route, and used that to extract all the possible information for designing the best ship for that route. And we selected the best ship of for that route, considering things like operational expenditure, consumables, and obviously pollutant emissions. This is on the left. You can see the location of the route, which connects the Eastern Peninsula with the Cres Island. And on the right, you can see an example of the data we used. Here we have a set of sampling of speed and position taken from January 2016 to June 2019. There are like 125,000 samples, and we use these profiles, data like this, for extracting the speed and the position samples, estimate the ship operation, and so on. Using the data, we evaluated different configurations for the propulsion system of the ferry, more than 4. I show you 4 only for example here, which start configuration that start from the conventional diesel mechanical propulsion system, which is the one actually used on that route, and then goes toward more hybrid solution with electrification and so on. We put some assumptions on fuel and shore power data and prices for doing the simulations, and we evaluated the impact of each possible configuration on the outputs. These are, as an example, the annual carbon dioxide emissions in white for the 4 configurations. We have taken the existing ship as a reference, and then we compared it with other solutions. You can see that the 4 shown solutions allow to reduce carbon dioxide emissions. They also allow to reduce the annual engine running hours, so less. So it will reduce also emissions related to maintenance of the engines and so on. And we also evaluated the operating expenditure for the owner. As you can see, for the series hybrid, which is the 3rd one, and the series hybrid with dual fuel, so with LNG, there is a high percentage of the operative expenditure depends on the power of the shore power, so the cost of the electricity given by the shore, because they have an onboard battery system which is charged by the shore. All the solutions that have some electrification allow to reduce carbon dioxide emissions, engine running hours, and also allow to reduce the operative expenditure for the owner. And this is significant because this means that the owner is not only pushed towards buying a new ship because otherwise the policies makes him pay more, or it cannot use the ship anymore. But it's also giving him a motivation regarding costs. We can both do something good for the environment and reduce costs. So it's good for the owner. This promotes the change of ships, the move toward a more sustainable transportation system. So we selected the series hybrid, the 3rd column in the picture, like the best compromise, because the 4th one, the best one, uses LNG, and none of the ports had nearby LNG bunkering facilities. So we selected that for designing our ferry, for doing our preliminary design. In this solution, we need to recharge the onboard energy storage system using the power coming from the land. So we need a shore connection. This makes both the price of the electricity and the presence of a correct infrastructure for supplying the required energy to the ship critical for the use of these ships. So we also, as I said before, analyzed the land side of the problem. This is a very short and easy example for demonstrating what we are doing in this regard. We have seen that there are some parameters that affect how the ship behave, the same ship behave, depending on the port side. The first thing is the presence or not of the recharge infrastructure in the ports on the route. It's only in one port, it's in 2 ports, and so on. Also, the shore connection power has a significant impact. Also, the time at berth, because the onboard batteries can be recharged only when the ship is berthed. So if the ship is berthed for very short period of time, we have no time to recharge the battery. All these parameters can have a really big effect on the results given by the same ship, which was the best one we conceived for that route. So I show you just a short example based on the same ferry on the same route, short route. In this case, we changed only the power of the shore connection for recharging the ship. We used a low power shore connection, which is the 160 kV one, which is sufficient for achieving the recharge during the night of the entire battery of the ship, but then cannot be used during the day. So the ship during the day works like an hybrid car, so uses its onboard generators for supplying the batteries for supplying the loads and so on, so optimizing its onboard operation without the support of the shore, and a high power, very high power shore connection for doing both the night recharge and then do a fast recharge every time the ship is berthed, which is something that happens a lot of times during the day, but only for 15 minutes. So the high power is required because the time is very short. These are some results using the daily zero emission navigation quota, which is not the correct environmental impact index for evaluating this, but it's very easy to visualize. So it's easy. It's easy to use it as an index in this case. So for the low power shore connection, we can define if during the day the ship uses its onboard generators at max power or max efficiency, and this has an impact on how much time the generators can be running or not. And for high power shore connection, we can decide to put the shore connection in one port or in both ports. And given the power level, this has a significant impact because the 2 ports in this route are very small ports. Actually, they have a less than 1/10 power installed on board. So they will need a significant refitting of the existing power infrastructure for enabling such high power shore connection for recharging the ship. We can see something very significant here, that the high power shore connection is both the one giving the best and the worst results, depending if it is installed only in one or in both ports. And also that the same ship used in different ways with different port infrastructures can have very different results. And this is an indication that the port infrastructure is relevant, and we need to address the port infrastructure when designing the ship. Otherwise, we cannot achieve the expected advantages from the ship. We may have designed the best ship, and then the ship performed very poorly because we didn't address the things that are on the outside, on the land side. So as a conclusion remark, we all know that electrification is one of the tools for improving the environmental sustainability of the maritime transport. But we also have seen during the project that the final result depends a lot on the input data on the parameters, like the cost of the shore power, the length of the route, the speed of the ship, and so on. This means that, first of all, we need to design different ship architectures depending on the type of the ship and the specific route we need to address. From the land side from the land side, we also need to take into account the port infrastructure, because the port may add constraints that have a significant effect on the ship, making it performing very differently from the expected performance level. And this means that there are cases in which we need to upgrade the port infrastructure for supporting the new green ships. So as a final remark, during this project, we have learned that the design of a more sustainable transportation system requires an approach which is integrated, which considers the ship in all its different parameters and so on. We need to optimize the ship. which is something that is already being done, and there is a lot of research on that topic. But we also need to address the land side of the problem and address them together, not designing the ship, designing a new port, and then maybe they will fit well together or not. Thank you for your attention.
Thank you, Dr. Vincenzotti. Thank you for your contribution, and thank you all for your accuracy, because we are perfectly on time with the agenda. So it's 11 o'clock and we can start with the first interactive poll. I will launch it, and the audience will have just a few minutes to answer those questions that you can see on the screen. So we will give 2 minutes or 3 minutes to answer these questions. The questions are: how informed are you about the sustainability of the maritime transportation? It's a multiple choice. What do you think is the main technology to decarbonize shipping? What do you feel is the main environmental concern with shipping? And the last one, it's a yes or no answer, is: would you choose a less CO2 impacting trip among several options if the information was clearly available? So we have around 30 people answering the poll. So the 37% is voting. One more minute to answer. Okay. I will end the poll soon, and I will share with you the answers. Okay. So now you can see the results. Can you see it? Does anyone wants to comment on the result? Can you please just tell me if you can see the percentage? Yes. Okay.
Yes, we can see. Thank you.
I can give my opinion if you want.
Sure.
Okay, I'm seeing that the public is somehow informed about the issues we are talking about, which is good. For the second question, what is the main technology to decarbonize shipping? It was like a tricky question because a lot of people said low carbon fuels, which is something. The tricky part is that we didn't ask on the short term or on the long term. So there is a good percentage that said low carbon fuels, but also energy storage system, voice planning, energy devices. For what I've seen actually on the international scene, low carbon fuels are one of the most important things in the short term, but also the other points that have a high percentage votation can be helping the both with low carbon fuels and without. What do you feel is the main environmental concern with shipping? Most of you said greenhouse gases emissions, which is what in fact is the one of the most addressed topics by the regulations. But a lot of people also voted on oil spills, which is something which is not addressed so directly by the actually, but it is a significant issue. And there is a lot of research and also some interesting solutions for that issue that are actually being presented. I've seen, as an example, a couple of weeks ago, some solutions for recovering nearly 70% of the spill when it happens, which I don't remember the numbers, but I think that with actual solutions, technical solutions, we are limited to 10-20%. So there are something which is coming to the market also capable of addressing that topic. And then we have a little bit of everything for the other topics, air quality, underwater noise, collision with marine animals. Finally, would you choose a less CO2 impacting trip among several options in the information world available? A lot of people say yes, and this demonstrates that there is a lot of interest in environmental topics in the past years. I think that the same question made 5 or 10 years ago will not have the same response. This from my side.
Thank you. Thank you for this comment. Does anyone else want to comment? Otherwise, we will go through the second part of this panel.
I want to briefly comment because Dr. Vincenzotti was really clear about most of the question. I will just add something about the last one, just because what we experienced was really peculiar in the last year. So we are talking about how people change their mind before and after the pandemic time that we are still living a bit, but because we experienced a really rising of this new sensibility about environmental impact of in every field. We are looking at this high rising of new electric car, installation of new electric infrastructure for a charge electric car, a lot of electric scooter, electric bike. So it's something that have a really cutting edge after this lockdown period. And so I totally agree with Dr. Vincenzotti when he said that probably the same question asked 2 years ago, it would have a totally different percentage of people. So it's really interesting, and it's just why we choose to pursue this aspect in our Echain project. Thank you.
Thank you, Dr. Gio. So I will interrupt. Okay. So now we will start the second part of the panel with other 3 speakers. I kindly ask to stay within your allocated 15 minutes. And so please welcome to Dr. Sergio Alda and Dr. Mercedes Garcia Orillo from the European Maritime Safety Agency. Welcome. We can't hear you. Okay. Now your mic is off. Okay, now it's open.
Now?
Yes.
Okay,
we can
fantastic.
hear you.
All right, so I was saying that good morning to all, and thank you very much for inviting us to this conference. It is a pleasure, and also following the previous presenters, we really like the subject. My name is Sergio Alda, and I will be doing this presentation that we have prepared for you together with my colleague Mercedes Garcia Orillo. We both work in the sustainability area, in the sustainability department in EMSA. And we have prepared this presentation, which is high level, because there are a lot of things that we can say about sustainability of maritime transport. So we will try to focus on the main subjects and still stick to the time allocated. So. Okay, so a few words first about the agency. EMSA is an EU institution. We are sitting in Lisbon, and there are over 250 people working in the agency from almost all EU nationalities. Our budget is around 80 million euros on an annual basis. And we undertake a number of tasks. We have operational tasks, vessel traffic monitoring. We have standby oil recovery vessels around Europe to assist in pollution incidents whenever they happen. We have systems like CleanSnet for detecting oil spills, providing satellite images of oil spills. And also we have a number of applications in support of European legislation. Our main task is to provide technical advice to the European Commission and the EU member states. The agency was created to deal with maritime safety after the sinking of the Prestige, an oil tanker, but it has evolved, and nowadays we are covering a range of activities, including pollution prevention. The area of sustainability has grown considerably in the last 10 years. I was looking into the polls before, and there was the question about how much do you know on sustainability issues regarding maritime transport. And I have to say that we have the perfect document to start with. We just published on the 1st of September the first European Maritime Transport Environmental Report. This is a report that covers all the environmental aspects of maritime transport, dealing from air pollution, water pollution, emerging topics like underwater radiated noise or marine litter. And we provide considerable information in this report to understand what is the actual impact of maritime transport in the various aspects. While working in the report, we of course went through the various areas dealing with sustainability. It is important to say that whereas in the second half of the 20th century, most of the focus was on oil pollution. MARPOL, the main convention dealing with pollution prevention, was adopted in 1973 and 1978. Air emissions, the focus on air emissions only started towards the end of the 90s. The corresponding annex was adopted in 1997. And ever since in the last 20 years, we have started to focus pretty much on greenhouse gas reductions. Greenhouse gases is now the main subject, but there are other emerging areas like underwater noise and marine litter. The report, the link is in there, and it contains, as I was saying, considerable information. It is true that maritime transport has an impact into the environment, but it is also true that it is essential for our economy, and this is evident because of all the data that we have in the report, maritime transport account for almost 80% of all the EU external trade and 35% of intra-community trade. The sector employs 1 million people. They carry 400 million passengers on a yearly basis, and up to 4 billion tons of cargo are being transported by maritime transport. It is by far the most efficient transport mode that we have nowadays. As I was saying, greenhouse gases is the main subject, and in line with this, the European Union adopted the Green Deal at the end of 2019. It provides a number of recommendations extending the emissions trading scheme for maritime transport, the uptake of alternative low carbon fuels and power solutions. But in order to deliver the Green Deal, a number of proposals have been brought forward by the European Commission. In 2020, there was the adoption of the EU climate law that will look into having the EU as a neutral continent by 2050, and the target of reducing greenhouse gases by 55% in 2030 compared to 1990 levels. Of course, all sectors will need to contribute to these targets. And when we look in particular to maritime transport, we know that globally, maritime transport accounts for around 2% of all the CO2 emissions around the world, slightly about 2%. And in the EU in particular, maritime transport ships calling to European ports account on a yearly basis for roughly between 140 and 150 million tons of CO2 emissions. We know that because we host the TETIS MRV application in support of the MRV regulation. And based on this regulation, all companies, they need to report on a yearly basis the total amount of CO2 emissions that their ships emitted on the previous year. 6% of these CO2 emissions occur while the ships are at berth. So therefore, the ideas that we were discussing about implementing electricity, onshore power supply, come into place regarding this, but not only. This year, on 14th of July, the European Commission, looking into this target of the 55% greenhouse gas reduction target for 2030, delivered what we call the Fit for 55 package, a number of proposals in order to deliver for this goal. The package of measures has to be seen as a whole, because there are aspects which are dealt with in the various different proposals. When it comes to maritime, there are a number of proposals which are quite relevant. From the one side is the extension of the emissions trading scheme in the EU to maritime transport, starting from 2023 already. That will impose a cap and trade on carbon emissions from ships. We also have a proposal for an fuel EU maritime that will target for a reduction of the greenhouse gas intensity of the ships on a yearly basis. There will be some reference lines, and ships will be obliged to reduce their greenhouse gas intensity and achieve these targets every 5 years. The Fuel EU Maritime will try to promote the uptake of low to zero carbon fuels and other alternative zero pollution technologies. It will also oblige to certain categories of ships, namely container ships, cruise ships, rope access and ferries, to also connect to onshore power supply from 2030 whenever this is available in the ports. Coupled with this initiative, there is also the revision of the alternative fuels infrastructure that now will be a regulation. It used to be a directive, but it will be a regulation, which will oblige certain TEN-T ports to install this onshore power supply based on the average of port calls on the previous years. So in the case of container ships, if the port in question has more than 50 port calls in the previous 3 calendar years, they will have to have availability of onshore power supply. The same goes for rope access and ferries, 40 calls in that case and 30 average calls in the case of cruise ships. There are other additional initiatives, one related to taxation. It will be the removal of the exemptions in the taxes regarding fossil fuels, in the case of fossil fuels used in intra-EU and inland navigation. And also the Renewable Energy Directive, where the target will be for the energy mix on EU member states to come from renewables by 40%, and the energy use on board ships will count towards this target. So it's a compilation of all these various measures that will deliver on this target of the 55 greenhouse gas reduction. Talking about the future, again, I would like to bring your attention to our publication, the INTERREG report, where we have considerable information, and we have an analysis of the pros and cons of the various alternatives and figures on the current uptake of the various solutions, from the use of biofuels, ammonia, hydrogen, fuel cells, batteries, and other solutions like energy or LNG, or installations of after treatment systems on board the ships. Just to say a few words on the current figures, we know that as of today, there are 30 ports around the EU which are able to provide high voltage onshore power supply, and opposed to that, from the ships that are calling into EU ports, roughly 200, less than 250 are, as of today, OPS ready, meaning that they will be able to connect to an onshore power supply if that will be available. 223 is of course still too low as a figure, taking into account the 21,000 ships that call into EU ports on an annual basis. We have some information on LNG ships. Of course, there are concerns about the use of LNG for the methane slip, but I mean those are issues that can be addressed from the technical point of view. As an additional item, I would like to highlight what we have discovered is that there is an increased uptake in the use of batteries as a complement to power on board. It can be clearly seen that in the last 3-5 years, there has been an increased installation in the number of batteries on board ships, and that will only continue in coming years. Now I will pass the floor to my colleague Mercedes that will continue with the presentation.
Hello, good morning again. Okay, so in order to achieve all these objectives in the Fit for 55 agreement, there is the need to study the new alternative fuels and power solutions to fulfill these new requirements. And for that, as some other colleagues have already presented, the European has EU-funded projects to evaluate the capabilities of this new source of powers or this technology, in order to check if this technology is already available, if it is the maturity of the market of the new oils, alternative oils, but also in order to check if there is the need of international or EU legal framework for that new source of power or alternative oils, as well as to develop best practice for the industry and operators. But it's also in these studies or this assessment that the research programs funded by the EU, the risk and safety evaluation is also a concern, and also the economic aspects of these new alternative solutions, in order to provide information to the ship owners and operations about the best alternative solution in their case. EMSA is also it's also carried out some studies and financing, and during the last year, since 2012, EMSA has been undertaking several studies about LNG, biofuels, ethyl and methyl alcohols, and batteries and energy storage. And from last year, EMSA has contracted a consortium of to work on a new studies on alternative fuels. We are now working in an update of the biofuels study to see the availability, the maturity of the market, and also the implication that these new biofuels can have on the design of the engines. And also for next year, we had just started this year on a new project, a new study about ammonia that will be finished probably by the middle of next year. And as this is a 4-year contract, we are also thinking in starting another 2 studies, one about hydrogen, and the second one most probably will be about wind-assisted technologies for ships. On the other hand, EMSA is also supporting the Commission on the onshore power supply as an alternative for reducing our emission in the ports and coastal areas. And currently, just at the end of the summer, we're finalizing this guidance on the use on offshore power supply for port authorities. And 2 years ago, we also produced a guidance for the use of LNG as bunker in ports. EMSA has been active supporting the European Commission, the environment, in the reduction of pollution from air, and particularly in the SOx emission. You know that at the European level, we have the sulfur directive, and EMSA was supporting the Commission in the implementation of this sulfur directive by carrying out visits to the member states in order to check the correct implementation of the sulfur directive, as well as delivering training and preparing drafting guidelines for sulfur inspectors. And EMSA developed a new module in the TETIS EU for sulfur inspection directive, where the sulfur inspector can report all the data gathered during the inspections, and also collect data from the previous one. And it's a very good tool for them to know how the ships arriving the ports are. So in order to make a risk assessment and going to for inspection the ones who really can be using not compliant food. In that regard, as you can see in these graphics, the implementation of the sulfur directive, you can see in the low graphic, is more or less okay, more than 95% of compliance inspections in the different sea regions. However, if we check in the upper graphic, we can see that NOx has been reduced during the last year, emissions, but it's not the same about NOx and particle matters. They remain more or less the same. We can, analyze this data, saying that perhaps SOx has this directive, and also with the implementation of the reduction in the SECA areas, this reduced in SOx emissions has been reached. But and we think that with a new regulation, macro regulation about NOx entering into force this year, perhaps we will see also a reduction in the NOx emissions. Also, as based on the experience that EMSA has with the SECA areas implementation, EMSA is supporting the Commission in the discussions at IMO for designated the Mediterranean as a SECA area. However, EMSA has also tools. I saw in the pools that the people is concerned about the oil spills. So EMSA has some tools to support member states in this surveillance and oil pollution response activities. One is the CleanSeaNet, that I suppose that most of you are familiar with, is a satellite-based system that takes a picture of the surface of the sea in order to identify polluters and give this information, pass this information to the member states in order to prosecute them in case of a real oil spill in the sea. And we have also, since 2017, a network of ARPAs, a contract with some ARPAs providers that they can be used by the member states also during the surveillance operation to support them, and also for SOx emission monitoring, as these ARPAs can be fitted with sniffers to monitor these the emissions from the ships in the area. Another system or another service that EMSA has to provide the member states in to help them support them in the oil recovery and response to pollution are the network of vessels. EMSA has a network of vessels for oil spill recovery all over Europe, and there is one here in the Adriatic area. That is the area that we are focusing in this seminar. And this ship is fitted with booms, skimmers, and oil pollution recovery systems, and it's ready to enter into work 24 hours after the request of a member state. The ship is already in place since the last August 2020, and by the end of this year, the ship will be also fitted with an ARPAS for supporting the operation recovery oil spill operations. And there is also a service of equipment based storage of equipment also for oil pollution response, also located around Europe, and there is an storage in Ravenna, Italy, ready to be used, but any vessel that could be needed in case of an oil spill in the Adriatic area. And finally, I would like to also to introduce the work that EMSA is doing regarding the underwater radiation noise. As per the INTERREG report that my colleague Sergio presented, there was an estimation in the report of a huge increase, the double in the increase of the double in the underwater radiation noise in EU waters. And as you know, the Maritime Strategy Framework Directive is requesting the member states to monitoring this underwater noise. EMSA is part as observer in the technical group of noise, this directive, and at IMO level, there was a request by Australia, Canada, and United States to review the 2014 guidelines for underwater noise, and EMSA is supporting the Commission in this work at IMO. On the other hand, EMSA has just finished a study on inventory of existing policy, research, and impacts on continuous underwater noise in Europe, focused on the noise sources, the policy, and the impacts of this noise. And for next year, EMSA will work in a model on continuous underwater noise from ships all over Europe, and will produce data and maps about the underwater noise in the European waters. And that's all from my side. Thank you.
Thank you, Dr. Sergio Alda, and thank you, Mercedes Garcia Orillo. Now, please join me in welcoming Mr. Alessandro Boveri and Ms. Erika Firenze from Catena SPA. Welcome.
Good morning to all. Can you see my screen, the presentation?
Yes, we can see it.
Okay, perfect. First of all, I would like to say thank you to our organization for hosting us and allowing us to present this topic. In our presentation, we will focus on two main topics that are very hot topics actually. The first one is the airborne emissions, and the second, underwater noise. For the second one, my colleague Erika will be the presenter.
Morning.
And then just a very few words on Cetena. Cetena is the consultant and research and innovation center of Fincantieri. So we are mainly focused on study and develop new technologies for Fincantieri and for our clients that are, for example, ship owners, port authorities, and so on. So our focus in our office, the mine office and the Erika office, is on the emissions, the environmental condition of the ships. So the topic of today. So first of all, I will talk about the airborne emissions. This, as already said by the colleagues in their presentation, is divided mainly into sources. The first one are pollutant emissions, and the second one, the greenhouse gases emissions. These two different sources may cause different impacts on the environment and on the people live. The first one, the pollutant, cause, for example, disease or impact on the environment. And the second one, the greenhouse gases, are the main causes of the climate change, as everyone knows today. Concerning the first one, the pollutant emissions, here it is shown the European share of emissions due to the transport system and the non-transport system. As you may see, in gray, there is the total emissions of pollutant from the non-transport sectors. And in yellow, it is reported the international shipping emissions. Here it is possible to see that for what concerns the CO emissions, the carbon emissions, the international shipping is not one of the most relevant sources. On the other side, for what concerns the NOx, the particulate matter, and the SOx, shipping is one of the main sources of this kind of polluting emissions. For what concerns the SOx, these are ruled by IMO regulations, and from the 1st January 2020, a new regulation has come in force, and so this value is more or less 1/7 of those presented in this plot. Here, the source is the European Environmental Agency, but the data set is dated 2019, so before the regulation coming into force. A normative roadmap is here proposed, starting from 2011. That is one of the first year where the normative come into force in order to decrease the total polluting emissions of our ships, with the first regulation on the SOx, with a total percentage of SOx in the fuel equal to 4.5%. Along the year, this value has decreased until the last year, 2020, where this value has come, became equal to 0.5 increasing condition and 0.1 at port condition. Of course, in emission controlled area, the Echain area, this value is even less, is equal to 0.1 in all the area. Other sources of polluting emissions, such as the NOx, are ruled again by the normative, by the International Maritime Organization, for example. And here we have, for example, the definition of 3 levels, the Tier 1, Tier 2, and Tier 3 level. That is a sort of index for the impact of different kind of engines or power generation systems on the NOx emissions. As you can see, these values are decreasing depending on the Tier 1, Tier 2, Tier 3, and this value is decreasing also over the year. Starting from the 2025, this should be equal to the Tier 3, so coming to force the Tier 3 conditions. That is also obtained with additional system over the power generation system that will be addressed in other slides. So I will come into this topic further in the presentation. Concerning the greenhouse gases emissions, here it is reported an equivalent comparison as presented for the polluting emissions. On the left, it is possible to see the total emissions due to the international maritime transport, depending on the total emissions due to the transportation systems. So, for example, automotive, train, airplanes, and so on. Here it is possible to see that the maritime is one of the most significant source of emissions, even if it is not the most impacting on this topic, on the greenhouse gases. In 2008, we have the peak in the emissions, and in fact, this is the year of reference for the normative in order to set the decrease of these emissions over the next years. On the right of the slide, it is possible to see the total emissions of CO2 equivalent, so the greenhouse gases, by different sectors. Here it's possible to see that transportation is the main sources of greenhouse gases. That is comparable with the industry sector. Other main sources are, for example, the power generations, so the electricity generation, buildings, and agriculture. Here it is possible also to see that the 80% of the total greenhouse emissions is due to fossil fuels combustion. That is the main source of power, of energy, that also it is used by the maritime sector. So it is in line with the other sector in this aspect. Starting from that, in the recent years, both the European Union and the International Maritime Organization have set different roadmaps for the decrease of greenhouse gas emissions and the pathway in order to decarbonize the maritime sector. On the left, we could see the objectives set by the European Union, that is to reduce the 90% of the greenhouse gas emissions due to maritime transport and both other kind of transport systems by 2015. On the right, we see the objective, the main focus of the International Maritime Organization, that up to now is to decrease at least 50% of total greenhouse gas emissions for the maritime sector. So, two different objectives. Probably the International Maritime Organization objective will be discussed again in 2023 in order to be more compliant also with European Union objectives. So a sort of trade-off between the two pathways to the decarbonization of the maritime sector. Here, on the left, it is reported the two sets, the two objectives that for the decarbonization of the maritime sector. It is possible to see that the same behavior proposed in the other slide for the total greenhouse gas emissions of the maritime sector. And below, there is a dotted line with the objective at 2030 for the decrease in greenhouse gas emissions by the maritime sector. The objective is to have emissions equal to 80 kilotons of CO2 equivalent emissions by 2050, up to now. Probably will be revised and discussed in 2023 at the IMO Congress. Again, here we have a pathway for the normative for the greenhouse gas emissions. In the last year, a push on the normatives has been occurred. In fact, we talk about anticipated IMO carbon intensity code. The pathway said that in 2021, guidelines for the development of two indexes. The first one is the EEXI and the second one, the CII, have been developed and shared by the International Maritime Organization. The first index, the EEXI, is a design index that assesses the energy performance and also the environmental performance of an already existing ship. And the second one, the CII, that is the carbon intensity indicator, assesses the environmental performances of an operating ship. These two indexes will come into force in 2023 with the EEXI with a required index that should be compliant with the performance of the ship. And the second one, the CII, will be calculated every year at the end of the year. And these evaluate also the total CO2 emissions of a ship over this year. After that, a rating index will be addressed to the ship from A to E. A, B, C, D, E are the performance indicators. And the ship should be compliant with at least the C indicator in order to be operate again in the years. These indexes are decreasing over the time. The CII index is decreasing over the time until the 2030. After the 2030, the normative does not give an indication, but probably will be developed over the time. Now, just a few words on possible technologies for the decarbonization of the shipping sectors. Here are reported the main technologies that are under study in our sector and also by Fincantieri. Here we may find traditional fuels with, for example, scrubbers, alternative fuel, SCR, that is a catalytic muffler, let me say, and the innovative generation system. So these are the main four categories that could be addressed by innovative technologies for decarbonization or decreasing the environmental footprint of the ship. First of all, for what concerns the scrubbers, here are reported the main technologies that are used in the maritime sector: the spray tower, the plate tower, and the Venturi scrubbers. Depending on different technologies, we have several benefits or, again, disadvantages. For example, the spray tower has large dimensions, so it is not easy to integrate on board a ship, this kind of technologies, and nozzle obstructions could be occur. Otherwise, the plate tower, for example, have a high contact surfaces, so it is very effective, but plate obstruction could occur again, depending on the different system. The Venturi scrubbers is the one that is less used on board ships because it is not so performing compared to the other two technologies. The scrubbers are mainly used in order to reduce and eliminate the SOx emissions due to traditional fuels, for example, the marine diesel oil or the heavy fuel oil. Mainly the heavy fuel oil, because it is the fuel with the high percent of sulfur inside. For what concerns fuel, for example, up to now, ships have integrated on board their natural gas which has a better performance for what concerns the SOx emissions, or the marine diesel oil, that is the traditional diesel with a very low sulfur content inside. Here we have different benefits and disadvantages, such as the cost or the storing conditions on board. Another technologies in order to reduce the NOx emissions of a ship are, for example, the SCR. SCR let a non-tire-free engine to become compliant with the tire-free normative. Finally, the alternative fuels that are probably one of the main answers for the decarbonization of the shipping sectors. The main sources are, for example, hydrogen, that has the advantages of zero emissions, because we have just water as emissions. But probably difficulties are, for example, the lack of legislation for the integration on board, and also a difficulty in storing this kind of fuel on board, both for volumetric reasons and also for safety aspects. The second one is the ammonia, that is a fuel with zero CO2 emissions, but has several difficulties, again, such as the safety and also the low flash point of a fuel. So these are main difficulties, and also it is poisoning. So difficulty for the human contact with this, with such a fuel. Last one is the methanol. Methanol do not reduce the CO2 emissions compared with diesel. However, could be produced with a net zero CO2 emissions, because it could be produced with renewable electricity and renewable CO2 coming from other industrial sectors. Has no SOx emissions and very low NOx emissions. So these are the advantages of methanol compared to the traditional fuels. Cetena may provide and also provide services both for the energy and environmental impact of the ships, such as the calculation of the IMO indexes, energy consultancy, and certified technical activities such as sea trials, electrical measures, and so on. So we are very active on this kind of topic, and especially today with a new normative coming to force. We have different infrastructures and facilities for the examination of exhaust gases, as you may see, for combustion analyzer, particulate matter measurements, and also smoke meter for the suit. Now I give the floor to my colleague Erika, that will talk about underwater radiated noise.
And good morning again. So my presentation will deal with the underwater radiated noise, since there's growing huge attention in the past years, because for a lot of years underwater radiated noise has been an issue only for some kinds of ship, such as military ship or research vessel or fishery ship, while actually it is growing attention also for the commercial ship, the ship passengers that are sailing, for example, in marine protected area and similar areas. There are different activities that have an impact in as a source of noise in the water. Not only the marine transport, but of course there are a lot of ships in our seas, so it is a growing attention by shipbuilders and designer of ship. In EU, some recommendation has been defined as some presentation before us, in particular for the ENSA presentation, the EU has been setting the MSFD directives. Some not EU countries, such as, for example, Canada or United States, has already give some noise limits defined, for example, at the port entrance, and sanctions have been already defined. But of course, it is a topic that is growing, and it is also the attention for our sector is growing up very, very fast. Typically, the noise, the underwater radiated noise from ship can be divided into two main sources, that is the self-noise and the radiated noise. The self-noise is the noise that is generated by the ship and detected on board the ship, while the radiated noise that is focused, which is my presentation is focused on, is the noise generated by the ship and detected in far field. Mainly, the main sources on board the ship are machinery that gives usually, as it can be seen in the graph on the right, typically tonal contribute, so at the specific frequencies, multiple of the fundamental. The main sources of ships is what do we say, propeller or the propulsion system in general. It gives contribution over a very wide field of frequencies, both tonal and broadband contribution, as it can be seen on the graph on the left. And also the hydrodynamic flow that gives broadband contribution. It could be very important, for example, for military vessels. This is a sketch of a simplified sketch of the transmission path of noise from onboard sources through the underwater radiated noise. So we have sources on board that can generate both airborne noise or structural borne noise that through vibration go into water. The propeller that re-radiate vibration to the hull or directly, because the propeller is working into water, and flow noise that have an impact both on the hull and also on the appendages of the ship. This is what I said before. So the EU has defined this marine strategy framework directive that has the goal to achieve or maintain the GES, so the good environmental status of the EU marine waters by 2020. On the other side, we have anything is already defined at IMO level. No mandatory rules are present, but are still present. But on the side of classification society, all the classification society has defined its own additional class notations. Of course, it is not mandatory, but it is actually on voluntary basis. The older one is the DNVGL class notation, but it is only on voluntary basis. CETENA works in this field, and it is a huge experience in this field, but in particular in the last 10 years, we have developed a methodology focused on mainly cavitating propeller, that it is able to predict at the very early design phases the underwater radiated noise from cavitating propeller. And the two main contributions are predicted through this methodology. The first one is concerning the tonal components, so at the frequencies multiple of the blade passing frequencies. And the other one is focused on the broadband contribution, both due to propeller tip vortex and broadband effects of ship cavitation. And the strength of our methodology is that we are doing both simulations, so numerical predictions, that can be validated through step-by-step measurements. So we can see which is the lack of our computational chain and which is the point to be improved. Because for the ship outflow at propeller disk and hydrodynamic propeller behavior and also propeller pressure distribution on the hull, we are measuring and with a Cyclope measurement system, we acquire simultaneously propeller video observation. So the cavitation, we catch the propeller behavior, and also we measure pressure pulses. And for the underwater radiated noise, we have our own acoustic array made of 3 digital hydrophones and 2 received station, one on the array and one on the ship to be measured, in order to evaluate the real impact in underwater of the ship. And this is an example of our activities with the hydrophone array into the sea and the ship that is sailing across our hydrophone. And we are also active in a lot of European projects that are working on this topic. In the past, we have taken part of both SILENT-D and Sonic projects. Actually, we are involved in PIACO and Saturn project. In particular, Saturn is the very first project that puts together all the acoustic and the engineering community with the biologists. So we are really evaluate the impact of shipping against the marine mammals and the fauna. So this is, thank you. We have finished. So I'm going to, okay.
Thank you so much. Last but not least, Mr. Alberto Cozzi, representative of the Port Network Authority of the Eastern Adriatic Sea. Welcome, Mr. Cozzi.
Yes, good afternoon. I will start the presentation. So I will briefly thank you also for the invitation, and thank you also to the previous speakers. I found all the speeches and presentations very, very useful and interesting. So today I will give you the port perspective, and more specifically the perspective of the port of Trieste. The ports of Trieste and Monfalcone. Port of Trieste is a core node in the TEN-T corridor network, and Port of Monfalcone is a comprehensive node. But they're both managed by the same public entity, which is the public, let's say, the Port Authority of Trieste and Monfalcone. As a port authority, we are a public body and we are a landlord port. So the private operators are those that actually implement the port activities. So there are private terminal operators, but our role is to foster the development of port infrastructures, and also to contribute, in this case, to the decarbonization of the maritime sector, also, of course, from a port perspective. But the first step is knowing how much CO2 emissions are generated by all port operations. And this is what we do. This is what we started doing 2 years ago. As all port authorities, we are obliged to use the guidelines for CO2, for carbon footprint calculations, which were developed by jointly by the Ministry of Transport and Ministry of Environment of Italy. They were published in 2018, so we started working on them in 2019 right afterwards. And we made a questionnaire for all the port operators. So the results that we have do not only come from ships, they do not only come from terminals, but they come from comprehensively all the port-related operations. So from the ships entering the port of Trieste, including the ships at berth, and all the let's say the port operations which are made on land on the quays. And these are the results of 2019. These are the results jointly by the port in the port of Trieste and Monfalcone. As you can see, not go into details because we do not have time, but most of the CO2 equivalent emissions come from the maritime side, and more specifically from the ship side when they are at berth, 65%. Then we have 8% of CO2 emissions coming from maneuvering ships, so ships moving from the anchorage to the port authority. So altogether, I would say that the maritime side accounts for 73–75% of the total CO2 emissions. But then we have also some other sources inside the port, and interestingly enough, 7.7% come from port operational heavy-duty vehicles. So let's say all the normal port operation vehicles. And I would like to underline something, that only a small percentage, 1% of CO2 emission comes from trucks entering and leaving the port. This was the first time that we made such a comprehensive and exact calculation or estimations based on the, as I said, Italian guidelines. And this is a powerful tool because we keep it updated every year, but numbers do not change that much. Because then we know where to tackle the most of the CO2 emissions. So we know that 65% of CO2 equivalent emissions come from ships at berth. So this is where we have to move to decrease that percentage. This is another, let's say, slide showing which kind of maritime traffic produces most emissions. Of course, the port of Trieste is an oil port. 2/3 of the total traffic comes from oil activities. So, of course, tankers contribute more than other ships to the CO2 emissions. So how we want to tackle this issue, CO2 emissions, how do we want to decrease it? Well, first of all, we have our own strategy that I will introduce later, and we try to implement the strategy thanks also to EU funds. And this is my job mainly. And we currently run 6 EU-funded projects, which are funded by different programs, INTERREG, Italy-Croatia, of course, but also Horizon and CEST, to decrease the the CO2 emissions. So, which are these projects? Well, Metro was already introduced by Mr. Vincenzotti, and in that project, for instance, we are finalizing the project design for the cold ironing in the Molo Bersaglieri, which is the cruise terminal. In Clean Berth project, we make smaller, say, investments in installation of charging stations for electric vehicles, but other ports do other things. For instance, the port of Venice has introduced some sensors for monitoring noise, and the port of Luka Koper in Slovenia, they introduced some sensors to detect pollution at sea. Susport project is another project co-funded by the Italy-Croatia program. In this project, we mainly, it's quite a big project, 7 million euros in total, gathering all the port authorities of Italy and Croatia in the Adriatic Sea, of course. We, as Port Authority of Trieste, we finalized the project design for cold ironing in the container terminal, but we also replaced all the lighting system with LED technology. Noemix is another project we are contributing to with, let's say, at the end of the day, we will replace all the internal combustion engine vehicles with electric vehicles that are used by the Port Authority. Healing project is a project co-funded by CEF program, so a completely different program, but in this case, We are finalizing project design for cold ironing in 3 terminals, in Roro Terminal, a general cargo terminal, and in the port of Monfalcone. And in Pixel, we have developed some port environmental index that was applied to the port of Monfalcone. So as you can see, different programs, different financing opportunities, but thanks to the EU projects and EU funding, at the end of 2022, we will have project designs ready for cold ironing for all the terminals in the ports of Trieste and Monfalcone alike. That is an extremely important result, because without that, we cannot continue with the installation of the equipment. So what have we done already? Well, first of all, modal shift. The port of Trieste is the first port in Italy for trains. And in 2020, 56% of the TEUs went by train to the final destinations, which are mostly Central Europe. And in this case, anticipating the target of the European Union, that is to have 50% of freight on train by 2050. But we also have a strong production of renewable energy. Almost 25%, 1/4 of the port's needs are covered by renewable energy produced by photovoltaic panels. We have an advanced IT systems, a port community system, which improves the efficiency of entry and exit of trains and trucks in the port, thus contributing to reduction in congestion and, of course, to CO2 emissions and air pollution. And we will also be working on energy efficiency intervention on port buildings. So as you can see, a comprehensive set of actions, not focusing only on one topic, but focusing on all the sources of CO2 equivalent emissions in the port. Some figures concerning modal shift. I will leave you the slide, so it's not so relevant for me to show you everything. Just underlining that the role of rail for the port of Trieste is essential for its competitiveness, but also for reduction of CO2. So currently 56% of containers of TEUs run by train, and 23% of semi-trailer. So I think this is a very good result. Others, as I said, production of electricity from renewable sources, already covering almost 21% of the total energy consumption in the port. And what do we want to do next? Well, first of all, not only thanks to European funds, but also thanks to national funds, the Italian government has allocated, will allocate 25 million euros for each port in northern Italy under the so-called Green Ports Initiative. So what shall we do? We will make the installation of the electrification of most of the ports berths in the ports of Trieste and Monfalcone, thanks to the designs that we made in the European funded projects. We would like to study the introduction of incentives for the electrification of operational vehicles that, as we said, account for almost 8% of the total CO2 equivalent production in the port. Of course, energy performance in buildings, replacing the public and internal building lighting with LED, but increase the energy production of renewable sources. This is where we can do it. The ports of Trieste and Monfalcone are not huge, so but covering the buildings would give us a good amount of renewable energy, and connected to this, the production of green hydrogen, thanks to the increase of renewable sources, mainly from photovoltaic systems. What are some, let's say, activities also that we are doing? We have to increase the awareness and incentives towards port users. We have to continue monitoring the greenhouse gas emissions in the ports, but what we also would like to do is to, let's say, widen the scope of this analysis. So far we have analyzed what happens in the port. So from when the sea arrives in the port to when the truck or train leaves the port. But what we would like to do, and we think is challenging but absolutely necessary, is to study the greenhouse gas emissions in a supply chain perspective. So only by involving the right stakeholders, which are the shipping companies, the terminal operators, but also the terminals that are in Central Europe where our goods arrive, and or the related railway undertakings, for instance, can we actually work together and find common solutions. We'd like also to achieve the 50001 certification. So some words about Koldarin. As I said, these are what we have been doing. If we imagine that in 2026, all the terminals will have cold ironing, will be cold ironing ready, then ships will be able to actually plug into our grid. Then we will drastically reduce that 65% of CO2 equivalent emissions. But there are some obstacles to be tackled. Well, first of all, the reduction, the small spaces in the port. As I said, Port of this is not very big, is surrounded by the city. So, and the necessary infrastructure is quite bulky. Then there is a lack of regulation. There's a low number of ships cold ironing ready, as we have already seen. We need to adapt the grid, the electrical grid, the national level, but we also want to add a fifth point, which is the cost. Because at the end of the day, if we do not make electricity, let's say, the same cost as normal fuel or less, then the shipping company will not certainly use it. So this is a point of interest for the national policymakers, but I would say EU policymakers, because otherwise there might be competition problems around Europe. Well, as I said, I've already I've already covered these topics. I have no more information for you, but of course I remain available for any questions later. Thank you.
Thank you, Mr. Cozzi. Thank you very much. So time is running out, so we will go directly through the second poll. You can see it. I will launch it. And we will have a bit more minutes than the previous one, because it has 8 questions. So we double the time to answer. And we will give around 5 or 6 minutes. We can read the question together. So the first one is, do you think that green hydrogen is a suitable solution in the short term for shipping or only in the long term? Multiple choices. Do you think that ports have a role in renewable energy production? In your opinion, which system produces less CO2? In your opinion, which are the main sources that generate underwater radiate noise from surface ship? Fifth question. How effective do you think the actual policies on pollutant emissions in maritime transport will be? Do you think that the actual policies on climate change will cause an increase in the cost of the maritime transport? What do you think are the issues of the actual policies on greenhouse gases emission reduction in the maritime transport? Last question. If you had to decide what policies should be prioritized, which 2 would you select from the list below? Are there 2 more minutes to answer? The The 22% of our audience is answering. As you can see, this poll is a bit more specific. And we will use the rest of the time to comment the poll results, to answer some questions. The 50% of our audience is answering. We have 1 more minute. I want to remind that the webinar will be posted on CMCC YouTube channel so that anyone can see it. Okay, hands out. I will share the results with you. And if there's anyone who wants to comment, please. The stage is yours.
Thank you. I will give some comments on the topics that are in my interest area, not on all of them. I'm an electrical engineer, so the question on the renewable energy production role of ports is interesting. I see that most of people are saying that they will have it into the future, but saying yes today and they will have it into the future because yes. Yeah, I think that this is something which is happening for the port, but it will be happening for a lot of different technical areas, industries, and so on, because the push toward reducing environmental impact will lead to most areas to install renewables, and so to sell them when they will have too much renewables. So yeah, the ports will be will have a role, but also other kind of industries and so on will have a role. Let me see. Okay, question 4. In which opinion, which are the main sources? No, not that. Sorry. I want to comment something on the policies. Okay, how effective do you think the actual policies on pollutant emissions in maritime transport will be? Most of you said somewhat effective, and the other go lower than that. So we can see that there is a point of not satisfaction from the people about the actual policies. I don't know if that it is because these policies are relatively recent, like the Fit for 55 euro policy, which came in this July of this year. So the people cannot have an informed point of view at present, because they are recent, or because there is effectively something which is not going as the people is expecting on these policies. But maybe the other questions are responding that. There's a lot of people that thinks that the actual policies will increase the cost of the maritime transport. Yes, it is also my opinion, but as I shown in my presentation, there may be some points for also reducing costs if all the points are taken together. As I said before, there is in our study we have found a solution that lowers the operative costs for the ship owner. Obviously, this is only an approximate study. You have to take into account the capital cost for both the ship owner and the port for preparing everything, but this may be something that can change also in the future, because the technologies are changing a lot. Maybe new, as a simple example, the lithium batteries cost is dropping a lot in the past, in the last 20 years. So they may be reducing the cost and so on. So in my opinion, it will be increasing the cost, but maybe not so much, or they will be only a momentary transition. It will be reducing then in the future. For what concerns the issues of the actual policies, yes, there is a lot of people that say that they lack coordination at global level. In fact, we have seen the Fit for 55, sorry, which addresses EU area, the IMO, which is addressing global transportation, the Paris Agreement of 10 years ago, nearly, which addresses only internal and coastal transportation and so on, which is so there is a lot more to be done in coordination, and this is also recognized by the public of the conference. Yes. Okay, they also do not consider interdependence between the different actors. Yes, okay, it's something I was expecting. Okay, but I will stop. I will leave the space to someone else.
Mr. Cozzi has raised his hand, so you can switch on your mic.
Yes, just a short, thank you. Just a short comment on the question about the role of ports in renewable energy production. Yes, certainly, this is true. The problem that we have, I would say, in all the ports in Europe, but most probably in the world, is space. Especially when we think that about cold ironing opportunities and installation that require a huge amount of power. And if it is true that we currently produce 24% of electricity in the port thanks to photovoltaic system, so to solar system, but thinking about the need for energy in the future owing to cold ironing, that percentage will drastically reduce. So the point the question mark for me is where to put all these energy production facilities in the port. Most European ports are inside the cities, so are surrounded by the cities, especially in our case, Port of Trieste, but also Port of Koper, Venice, and so on and so forth. So the role of ports, yes, but maybe we should look at the sea. Our ports colleagues in the northern range, for them it's easier because they have the Northern Sea and they have windmills for renewable energy production. Maybe we should start studying the same thing also in the Adriatic port. Thank you.
Does anyone else want to comment the results of the poll, or otherwise we have a question from the audience? I don't know if someone of you wants to answer. How much air and sea pollution receives Italy during strong bora or scirocco wind conditions?
No one. I sincerely, I don't know. I never addressed such topic. So because it's not my area of work.
Well, I think you should look for the Copernicus Atmospheric Monitoring Service for that, which is a service specifically developed and funded by the European Union for computing the advection of air pollutants throughout Europe and beyond, so including aerosols and gaseous precursors. I can share the link, I think, for the main portal. I hope so. I will try to do it in the chat so everybody gets it.
Thank you. Will be useful. Does anyone of you add something?
Yes, I'm the only one talking today, but sorry for that. Yes, connecting to what Alberto said about the use of the sea. Yes, I want also to remark that in fact the ports have this huge resource, which is the sea, and there are some proposals and for using that offshore. Let's call it offshore. It's in the Adriatic here, but it's offshore in our small type of vision for installing for using that space, offshore space, for installing renewables and so on. Also for installing support systems for all the new ships, like using bunkering facilities for LNG, which are not on the shore but are offshore and so on. So there, I remember there were a lot of discussion on these topics, and it's I think it's actually one of the topics of discussion in the area. I want only to say that in regards to the last poll question, which is the question on what policies should be prioritized, that there is the responses are almost everything with the solutions to reduce environmental impact of ships, which is the most selected, and also the fines to anyone who pollutes the environment is a good selection, as well as tightening control over pollutant emission for ships. So okay, there is a lot of focus on ships, but as I said before, there is important, as I said before, as Dr. Cozzi said, there is something that can be done also on the land side, which is maybe small now. As Dr. Cozzi said, they had most of the more than 70% of emissions due to ships, but if we achieve the reductions that are required by the policies for 2050 and so on, the remaining part will become the part that will be needed we will need to address in the next future. So yes, we will be focusing on the most impacting factors now, but we don't want to forget that also the other points can be addressed and will be addressed in the future. So I don't know, we need to do research and to provide solutions also for that future point.
So if I may step in, I would like to comment on question 7 and 8 about the policies. I would like to make the point, as a scientist working for a center working on climate change, that the general weakness of present policies is that they are not science aligned, in the sense that they are not able to reach the Paris Agreement targets of limiting global warming and its detrimental consequences. This is actually true even at the level of lacking self-consistencies of some of this policy, specifically at IMO level. I mentioned in my talk that the carbon intensity target of IMO is presently not consistent with the absolute emission target. So the absolute emission target of IMO is to halve emissions by mid of this century compared to 2008 levels. And this will not be reached with present IMO carbon intensity targets and forecast transport work pathway for the next decades. So there is a lack of there is a point of lack of self-consistency, first of all. Then, I mean, there are, of course, we can see the glass as half full, because finally there is some mandatory tool starting from 2023 for reducing carbon intensity of ships globally. And at least at EU level, there is a more ambitious plan to force this increase in efficiency, reducing and dropping emissions through financial mechanisms such as the inclusion of shipping's emissions into the EU ETS. However, I think the financial instruments are not only those set in place by the regulators and the institutions, but also those mechanisms self-activated by the market. And in this, I refer to the fact that the customers might require the ship owners to carry their goods on ships which have a high requirement in terms of limiting their emissions. So in this respect, there is lots to come, I think, in the next few years, and maybe market forces might join together with regulatory efforts, or may not. So this is not clear what will happen. What is sure is what is happening at present. So the speed at which emissions or emission intensity is being reduced is not sufficient for shipping to deliver a proportionate contribution to the target of global emission reduction for limiting global warming.
Okay, and you said you wanted to comment also the last one. Okay, so if it's okay for you, or you don't have other argumentation or contribution to give us, I will go to the conclusion. So we were here today to answer a question. So can the environmental sustainability of touristic maritime transport in the North Adriatic Sea be improved? So this was the main challenge we wanted to face today together. And as far as this panel is concerned, the answer is yes. And each of the professionals here speaking has given important tips and contribution to achieve this goal. Of course, the CO2 emission causing, of course, the 80% of greenhouse gases is one of the core challenge. Every one of you said so. So to make fundamental to reduce the effect of pollution and put more energy efficiency, you highlights some other important themes that came out from the session, such as decarbonization of shipping, energy saving devices, the use of renewable energy sources, optimization of the ships and ports infrastructures, energy efficiency intervention on ports. And I wanted to conclude saying and underlining the importance to combine technological and engineering action with logistical actions in a way to develop a more integrated approach to the core issue that, of course, is environmentally friendly maritime transport system. So I would really like to thank all of you for your participation and for taking care for this session. I remind again that the webinar will be posted on CMCC YouTube channel. And thank you for your participation. Thank you for your proficiency and accuracy.